Okay, today let's talk about Leetcode 3326. First part is the description. You are given an integer array numbers. Um, the length of it is n. You can do several times of operation to this array and become it a no decreasing array. For every operation, you can you can choose any of the elements in this array and divide it by the largest divisor. That means the largest divisor except itself. It means, for example, for the 6, the divisor includes 1, 2, 3, 6, but you cannot divide itself. So the largest divisor is 6. For another 12, the divisor includes 1. Actually, 1 don't have any meaning. We don't need that. So for the number 12, the divisor includes 2, 3, 4, 6. That's all. Yeah, that's all. So the largest divisor is 6. If we want to make an operation for the number 6, we will make it 6 divided by 3 to 2. If we made the 12, that means 12 divided by 6 equal 2. This is the explain about the operation. What you need to do is find the minimum possible numbers of operations. After that, we can become the original array, a no decreasing array. This is the description about this problem. Next part, let's talk about solution. For this part, actually we can check or do several operations for every element from front to back or back to front. But if we do that from front to back, we will find, if we find the number, for example, if we the length of the value of the number, if we found that the third number is very small, we cannot make the third value larger. We cannot do that because what we only to do is make it smaller. So we need to make the first two elements smaller. But this is very complex. If we found the value is this kind of, if we found the small value in the last round, we must process the previous many elements smaller. This is complex. But if we do it from back to front, that means we need to check the last elements and the last before last one, the one before last one. If we find this is larger, so what we only need to do is make it smaller. After we process several elements, we don't need to process these elements again, because this is the only way to process them. So we can process these elements from back to front, from last one to first one. If we found every element is larger than the last one, we need to make it smaller. That means do an operation to it and divide it by its largest divisor except itself. So this is what we want. What we should do for the first part, and that means process from back to front. This is what we need to do. For every operations, for every elements, what we should to do. Actually, for any number, that means we can make it x divided by largest. A divisor. Actually, this value will be the if there is a largest divisor, the value after divide will be the smallest primary number among different divisor of x. What means for example, for a specific x, and there are several advisors of x that can be a1, a2, a3, a4, a5, an, maybe an. That means they are all the divisor of x. That means x plus 0, x plus 0 plus 0. For the largest divisor, there always be a formula. That means a plus 1, the smallest divisor plus largest divisor equal x. So if x divided by the largest divisor, the value will be the small divisor, and the small divisor must be a prime value. That means because if a1 is not a prime value, so a1 will be equal p plus q. So p and q must be divisor of x. That means p and q must smaller a1, smaller a1. So pq will be smaller divisor of x. That is different conclusion with the previous assumption. So what I want to say is x divided the largest divisor must be a prime. That means after you do an operation to elements of the array, you cannot do it again, because after one operation it will become the primary number. Actually, if you don't know this conclusion about the problem, you also can solve this problem, because the consuming time is very high. Actually, if you want to so for every elements, the first thing we can do is get the primary list in limitation value. That means we can get a primary list in a specific array. That means 1 million, because the limitation of every element in the array is 1 million. For example, the primary list rule will be 2, 3, 5, 7, 11, We can get the primary list. So for every operation, we can check every prime is divisible by x. If it is, the x will become the small list prime. This is what we can do to get the value after one operation. This is first solution. Actually, you also can check every number. That means you also can check number from 2 to larger. That means from 2 to x. What we need to do is x. That means I. That means I plus I smaller than x. I plus. So if the x is divisible, that means equal 0, so x will become I. This is also acceptable for this problem because we know I will be the smallest. Actually, we know I must be a primary value. It always be a primary value, and it is the smallest divisor of x. So x will become I after one operation. This is also acceptable for this problem. Okay, this is all about the solution for this problem. So the last part is complexity. First, first of all, is time complexity. For the time complexity, there are two kinds of, and there always be n. You need to check every element in this array. So, second is you must. There are two ways to process every value. For the second way, what you can check is the time complexity will be SQRT 1 million. This is the maximum value of every element because the length of this loop will be SQRT. For the first solution for this part, for primary list, what you need is n log n. Maybe n log n. This is very similar with n log n. And this list will be very short. For example, for the 1000, it's about 100. That means there are 100 primary value in the range of 1000, and the maximum primary value what we need in this problem is 1000 because 1000 the square of 1000 is 1 million. For the first part, that means equal, almost log n. Actually, it's not log n. That will be 100, about 128 in my experiment. So the time complexity will 108 n or 1000 n for this problem. This is the most bad situation for the time complexity. So the truly consuming time is better than this value. Second is space complexity. Actually, we don't need extra for the first thing. We need to get a primary list, so we need extra space to store the primary value. So it will be the time complexity will be 2n, and the second is O(n). So the finally space complexity will be O(n). So this is all about this problem. Thanks for your watching.